Alright, so for number one, we're trying to find the velocity in part A. Remember, velocity is just the derivative of position, so we get 3t squared minus 12t plus 9. And acceleration is the derivative of velocity, so we get 6t minus 12. In part C, it asks when is the object moving to the right. So we just talked about this. An object is moving to the right when the velocity is positive. So we have to figure out when is the velocity positive. To do that, first we're going to have to figure out when the velocity is 0. We're going to do a number line for velocity, so kind of going back to the beginning of this chapter. So I'm going to figure out when is velocity 0. So I'm going to factor out a 3 first to make the trinomial a little bit easier to factor. We get t minus 3 times t minus 1. Now, some of you have been making this mistake in the past. We can't set 3 equal to 0. It's not possible. There's no variable there. Some of you will say, oh, t has to equal 0 because of this factor. No, it can't. It can only equal 3. There's no variable. But these two give us two answers. We get t equals 3 or t equals 1. So we're going to look at those on a number line for our velocity. At those points, the velocity is 0. We want to figure out what's going on in between these. Now, I forgot to write this in the problem, but in most of these problems, or some of the ones you'll see, it'll say this is for when t is greater than or equal to 0. So we're going to assume that we're starting when t equals 0 and only looking at positive times. So we're going to go ahead and plug in. I'm going to put in 0 because I want a value to the left of 1. I'm going to put 0 into the derivative here. So this is going to be positive all the time. 0 minus 3 is going to be negative. 0 minus 1 is negative. So positive times a negative times a negative is going to be positive.
Wait, so you don't plug it back into the original?
No, because what are we looking at? This is a number line for the for the velocity. So I want to know what's going on with the velocity. Then if we're going to do 2, put 2 in. This is still negative, but this one's positive. So positive times a positive is negative. And then if we put 4 in, everything's going to be positive. So when we multiply all those, we get a positive. We're trying to figure out when is the object moving to the right. So that's when the velocity is positive. That would be from 0 to 1 and from 3 to infinity. All right, for part D, I want you guys to figure out when is the object's acceleration negative. Go ahead and try that one on your own. All right, let's take a look at part D. When is the object's acceleration negative? Well, just like the last problem, we would need to figure out first, when is the acceleration 0? So our acceleration was 6t minus 12. If we solve that, we get t equals 2. So I'm going to make a number line for acceleration. I know the acceleration is 0 at that point. I want to figure out what's happening on either side so we can figure out when the acceleration is negative. So if I put in 1 into our acceleration, 6 times 1 minus 12, that's going to give us a negative value. All of those accelerations to the left of 2 are going to be negative. Then if we put 3 in, we get 18. That's positive. All the accelerations to the right of 2 are going to be positive. So we were asked when's the object's acceleration negative. That's going to happen from 0 to 2. All right, let's take a look at part E.
So we don't put in negative infinity because of the...
Yeah, from when time is greater than or equal to 0, yeah. So for part E, what is the velocity when the acceleration is equal to 0? Well, in order to find velocity, we need to have a time to plug into that equation. Remember, our velocity equation, v of t, is 3t squared minus 12t plus 9. Well, we want to do it when the acceleration is 0. We kind of figured that out in the last problem. Acceleration is 0 when t is 2. So for this one, all we're trying to do is figure out velocity when t is 2. So we're plugging 2 into our equation. 3 times 2 squared minus 12 times 2 plus 9. So we get 3 times 4 is 12, minus 24, negative 12, plus 9, we get negative 3. And this was in meters per second. The original problem told us that the position was measured in meters, time was measured in seconds. So this is negative 3 meters per second. Now if it asked for speed, we would just say it's 3 meters per second. Remember, speed is absolute value of velocity, it's always positive. But velocity, here it's negative, that tells us the object is moving to the left. All right, let's take a look at the last part for this one, part F. When is the object speeding up? Remember, that has to happen when velocity and acceleration are both positive or both negative. Well, we've already done most of the work for this. We have an acceleration and a velocity number line. What I'm going to do for this problem, for the speeding up, is I'm going to combine those into one number line. I'm going to put change the colors here. I'm going to put the velocity on top, and I'm going to put the acceleration on the bottom. What's up? Physics all over again? Woohoo! Go Mr. Ailes. Alright, so on our number line, we had 1 and 3 from our velocity number line, and then we had 2 from the acceleration number line. So with velocity, we saw that velocity was positive when it was less than 1, so it's going to be positive over here. Negative from 1 to 3, so negative in both of these little spots. And then positive when x was greater than 3, or t was greater than 3. And then on the bottom, we're doing acceleration. Acceleration was negative when t was less than 2, negative there and there, and positive when t was larger than 2. So we're looking for those spots where velocity and acceleration have the same sign. That would be this interval and this interval. So it's speeding up from 1 to 2 and from 3 to infinity. If we were asked when is it slowing down, we would look at 0 to 1 and 2 to 3 because the signs are opposite. They're working against each other.